we can get going in the meantime, or at least give a little bit of opportunity to familiarize yourself with the tools that are on the call. We like this to be a bit of an interactive call, so it would be great if you guys ask questions that you may have throughout the whole presentation, throughout the webinar. You can just find the activities button on the bottom right of your screen, where you will see a Q&A section, and our members on the call will just watch out for any questions that you have as we're going through. So feel free to just ask away if you need help with anything, or if you have any questions. So
indeed. So don't hesitate to stop us. Mike is going to lead the webinar, but I'm going to be the first one to come in and stop him here and there and see where else we can go. But please, anyone who has any thoughts or questions, please do the same, and then we're happy to stop, because at the end of the day, the whole point about this is not for us to talk amongst each other and tell you how cool we are, but to answer your questions, to make this interesting and useful for you guys. So really do not hesitate to chat and ask questions if something comes up.
Okay, cool. Let's jump straight into it. So the topic today is obviously AI inspection, and that's all around automated quality inspection. And just so that we're on the same page and we all know what exactly we're talking about here, to give you an idea, is basically having an inspection system that sits either on your production line or in a standalone station that automatically detects defects on your product and does your quality control process for you. And that includes defect detection, and includes component verification, and includes any other service quality parameters that you might do in your manual inspection, or in any inspection solution that you might currently have set up on your line. Now, AI is a bit of a buzzword, so AI inspection obviously can come in many different stages. That can be in the way you process the images, or in your reporting process after the inspection is complete in the station. And these kind of opportunities that AI unlocks is what we're going to cover today, and give you an idea of what you can do with this automated quality inspection, because a lot of people tend to overthink it and think it's for very specific use cases, and they overlook the opportunities that it can hold for your production line. Now, the first bit is why should you even consider AI quality inspection? And there's a lot of advantages to adopting an automated inspection solution, and these are the three pillars of those advantages. Obviously, the main one is saving costs by optimizing your quality inspection process, and this can be because you start catching defective parts or defective components earlier in your production line, and by pulling those off the line and reducing the number of resources you're putting into manufacturing a certain product, you can start saving your costs, and you're reducing scrap and all those kind of goals that come with the automated inspection solution. Then obviously you're saving time by reducing the many different steps that you might be doing manually in your inspection process. Because when you're doing manual inspection, it's not just about spotting a defect or just about looking at the product, but obviously you have to report what you're seeing. You have to take note of what you're looking at on the products. When you come across a defect, it can take time to report these things. Also, documenting those defects takes a bit of time. You might be taking images of the defects. All that stuff adds up and accumulates to a long inspection process. And by automating the process, you can kind of cut down on the time spent in inspecting each of your products. And then obviously the last one is freeing up labor and gaining consistency in inspection. Now, with manual inspection, there's obviously a lot of human error, human fatigue in inspection. We've spoken to a few clients in the industry that are doing manual inspection, and some of them are inspecting thousands of parts per day, and it's a single person spending a lot of time staring at the same part coming through the line, and you can imagine they're getting tired. They start missing certain defects. Even if they change shifts and the next person comes along, they might look at defects differently. What they consider okay and not okay might be slightly different to the previous person. And that also comes in the supply chain stages as well. So AI inspection can kind of help standardize your inspection process and make sure you're getting consistent quality control outputs throughout production.
Mike, let's stay on that point for a moment, because I think that's actually quite interesting, and this would be a great point for anyone on the call to perhaps also share their own experiences, because this is also connected to a question that we sometimes get, like, oh, so you guys come in and you replace what we're doing. Does that mean do you want us to fire our workers or whatever? Or especially someone who's not in that space themselves sometimes asks this question. So this is an important point and a great point that really showcases that that's not how it works for us. So like Mike just said, in many cases we see that this is just a bottleneck because of the limitations of what's humanly possible, right? In terms of also fatigue and the ability to concentrate. So, for example, yesterday we had a great case with a steel manufacturer, and they have a person who has to look at several thousand pieces every day, and it spends about 10 seconds per piece. I mean, imagine that day in, day out. That's what you do all the time. It's of course you can't focus, right? Of course you make mistakes. Of course when you're near lunchtime, it gets worse, right? Or if there's not a dedicated inspection person, in many cases, what we found is that manufacturers rotate their engineers or their general staff through that role, as in they don't have a dedicated inspection staff because they know of these problems with fatigue. So more or less anyone on the team has to spend 1 hour a week on the inspection job, basically. And everyone hates it. Nobody likes to do it, right? So this is a really important point. We can free up that resource, and we can really come in and help, not waltz in and say, oh, okay, we're replacing you and we show you how it's done, but rather, hey, here's a cool tool, and that makes your life a lot easier.
Yeah, I think another example of that we've spoken to in the past was a bit more of an intricate or complex part that they were inspecting. And one inspector, as soon as they start an inspection on a part, they're not allowed to stop until they've completed the entire inspection. And an inspection of that one part could take up to 6 hours, which is obviously very tiring for them. As you can imagine, concentrating for 6 hours straight is quite fatiguing. So that's obviously a big advantage that AI inspection unlocks in your QC process. And obviously with this, like with the time savings, with the cost savings, and like through freeing up labor, you start unlocking a number of these goals that AI can achieve for you. And that's the main ones being higher production yield and reduced waste in your production process. And these are obviously all very desirable goals to start achieving in your production lines. Now, another thing that's really important to understand is the capabilities of AI inspection. I think a lot of people look at these automated inspection solutions and immediately your brain goes to a camera pointing at a product looking for defects. And a lot of the opportunities are missed and the capabilities are missed in what AI inspection can do. So obviously the main one is going to be defect detection. And these three are kind of joined. So detection, measurement, and classification. So you can obviously have cameras or other sensors on your line that pick up whether there are defects on your parts, and those pass-fail conditions can be set by you. So you can say you're allowed a bubble or an inclusion that's up to 2 millimeters, but anything above 2 millimeters is a defect, is considered a defect. And the AI can watch out for these types of conditions for you on your line. And the other ones are obviously the OCR and component verification and barcode reading, counting, and conditional logic. So with stuff like component verification, I think people don't necessarily consider AI inspection as they would for defect detection. But component verification could be anything from just checking that all the parts and components of your product are there and that they're in place correctly. So this could be whether a bolt is loose or a screw is loose or whether it's tightened correctly. That can all be done through AI inspection as well. And in your QC process, there's obviously a lot of cases where you're combining a number of these into your solution. So you might need to do OCR and defect detection and component verification all in one solution, as well as maybe barcode reading if you're trying to identify parts by ID or something like that along your inspection process. And the more complex the solution becomes, you'll find it becomes harder to implement, but also a lot of providers out there will be specialized in specific components of these capabilities. Like they might do defect detection and measurement really well, but when it comes to classification, they're not so great there. And when it comes to OCR reading, maybe they don't quite cover that. So you end up kind of putting all these puzzle pieces together, and you end up with a solution that maybe is not quite what you expected and doesn't unlock those advantages that you saw previously. So I think when you consider AI inspection, it's good to know what you need in your process right from the start, and find a solution that covers everything that you need in the inspection process. I think I saw a question there. It's something come through.
Yes, there was a question. How precise can you measure, and how do you calibrate for precise measurements? So while we try to keep this webinar a little bit more on the informational side rather than the direct sales side, I'm happy to talk about our specific solution as well. But in general, usually the precision is if the AI is worth anything, the precision is usually driven by the hardware. So depending on what kind of hardware you're using, what resolution is available, you can usually find an AI that can deal with that as well. And the same thing applies to us. So it really depends on what your use case is. If you have something that is sub-millimeter, you have to go very high resolution camera or optics that go microscopic, right? That's not a problem. It just depends on what do we see and what do you want to classify there. It becomes a lot more complex on the AI detection as soon as you go microscopic, because usually microscopically uniformity disappears. So one of the things that I think later on we may come across that one of the important areas that our particular approach with synthetic data is very good is that non-uniform parts, because the parts become so difficult to deal with, because every single time you look at it, there's so much chaos, there's so much stuff happening that AI can be easily confused, right? So that's where one of our strong suits are, that we can deal with that, with the funky things or the funky way things present themselves once you go very low size when you go very microscopic, essentially. The second part of it, how do you calibrate for precise measurements? Again, it depends on the area of application. That's less of an AI question. It's more of a hardware question in most cases. And here it's usually an interplay between ground truth information, for example, distance to the sensor or the calibration of the sensor, and what you're looking for, right? Perhaps something that would be important to mention here is an alignment between what you define as the right measurement or classification and how we translate that. You can see here on the bottom left there's an interesting example of the bubble, and that we have found to be almost a philosophical question at time, because where do you define the beginning of that bubble, right? And then depending on that, how do you measure it? And that's very important for us to have that direct conversation and interaction with the customer to define exactly where do you want to start measuring and where do you want us to end measuring. And then we just adjust to that, essentially. So we just replicate the way you're doing it.
I saw another question on an example of conditional logic. One of our previous clients, like this comes down to complexity of inspection. So where you might have a certain defect like this or the bubble, it's easy to spot the bubble. But then when it comes to things like pass-fail conditions, those can start stacking up. So a very simple idea is what I said earlier. If it's below 2 millimeters, it's okay. If it's above, it's not okay. But this can get a lot more complex. So with our previous clients, they had conditions about clustering of bubbles. Like you could have a number of bubbles in one location, on like a specific location on the product. And if it exceeded a number of bubbles, that would count as a fail condition, as well as the measurement of those bubbles, the spacing of the defects. All of these things can start stacking up into what can be conditional logic. And it can also be something that you account for in the hardware. So what to do with the product if it fails. Like if it fails, then move the product off the line, or have some sort of sorting station that sorts the failed and passed products out on the production line. And just to kind of dive into the defect detection side of things. So like I said, those three kind of go hand in hand: detection, measurement, and classification. And as you can see here, as the product's coming through the line, or you're inspecting a specific product in a station, the results of the detection can classify the defect. So you can say there's a dent or a bubble or a scratch. It can also measure that defect, give you an output of the measurement. And then there's a few different outcomes that can come from a detection result. So your product might have no defects, in which case it's a pass. There might be a known defect detected, in which case the result is output. And in some cases, there might be an outlier detected. So if you've covered a certain number of defects in your inspection solution, but maybe a rare defect occurrence comes across the cameras or the sensors, the AI might still be able to pick up the defect, but it will ask for input from your inspectors or input from a human to tell it what kind of defect this is, so it can feed back into the system and train the system. Okay, maybe this is a new type of inclusion in the product that needs to be flagged whenever it has certain conditions. And then the system can start learning from that to start detecting that reliably and classifying that defect in your inspection. And one thing that comes with AI inspection is not just about detecting the defects on the line and telling you, okay, there's a defect. It can also be included into your reporting process. So it can output the results of its detection, including the classification, where it appears on the product. A lot of the time we use product defect defect maps, so you can see exactly where defects appear on the product, and it can kind of guide the inspectors or whoever's receiving those reports to see exactly where that appears on the product. And then it can do the measurement, and you can start adding on additional requirements in the end. So if you need a category for whether it's serviceable or not, and whether it requires repair or not, or can be repaired or not, can also be decided by the AI. So these are kind of additional steps that AI unlocks in the inspection process, as opposed to just traditional machine vision. AI can start making your inspector decisions that your humans would be making in the product. And obviously, with that human in the loop feedback that I spoke about earlier, throughout the reporting process, your inspectors can be commenting or overriding inspection results. Maybe there was dust that appeared on the product, or something that was removable, or if it's been serviced, they can then change the outcome of that inspection and then move it along the production line. And
Mike,
obviously,
can we stay on that for a second, because there's some really cool points in there as well that are really speaking to second order effects, because the first challenge is to have the proper inspection and have the proper reporting, right? But where the true value creation comes in a second step is taking that and translating it into improvements on the production line or in your processes, right? And this is really cool, because we can, if you have an inspection AI, if you have a system that understands these properties, you can translate it not just into these reports, but as Mike just said, also into very, very fast and precise recommendations and instructions for reworking, for repair, for improvements potentially. And we're about to get to that in the next slide. When you have several inspection stations, especially, but just from a single one already, the amount of friction that can be reduced, the amount of time that can be saved, if you can very quickly go from the truth about your quality parameters to the next actions and what to do with it, is fantastic. And then also on the bottom right here, this expertise capture is a really important point as well. Something that we perhaps not always emphasize sufficiently, but we've and this is something that we have totally learned from our interaction with customers, that this is tremendously valuable, because they sometimes have inspectors who are the best out of the team, right? And quite often they are very experienced, but also they might be about to retire. So how do you make sure that all of that experience, all of that ability is captured, right? And yes, the obvious and simple answer would be, oh, of course, you just train the AI with it. But it's not that easy to do that. You need to have proper mechanisms that allow you to do that. So in our case, we've built in mechanisms for exactly that, to have this expertise capture, to not just provide an override yes or no, or yes, this is a right judgment or this is a wrong judgment, but we always offer the actual opportunity to explain, to redraw, to assess, and provide precise feedback and explanation, both of which can be captured. So not only the result in the future can be adjusted based on the expertise, but the actual explanation can also be supplemented. So a future inspector, a future supervisor sees why the system does this, because it has learned from the previous expert, and also learns exactly the reasons why the expert did this. So this is all, it's sort of peripheral to the main challenge of machine vision, but it's an important part of the overall solution and part of the holistic approach that we're also trying to achieve.
Yeah, and with that, like this gathering of data in your inspection process and this documenting of all your inspection data kind of unlocks a lot of insights into your production line. You start getting these analytics about your products, about defect trends, and this kind of helps you tackle some maintenance challenges. It can alert you to maybe something going wrong with your production line a bit earlier on. And the true value gets unlocked when you start having multiple stations along your line. So if you have a long production line or long production process, having multiple stations throughout the process can unlock some correlations in the inspection results at each station. So where something might present itself at the first station really early on in production, might be detected at the second station towards the end of production as a defect. And AI can kind of match this and correlate this these results to then start flagging that defect at the first station. So you stop wasting resources and putting in too much work into your products to then continue manufacturing them when it's a lost cause, essentially. And one of the success stories or reference cases is this aviation glass, which manufactures these glass panels for the interiors of aircraft. And these are really expensive products to produce. And they had some complex defect criteria and inspection criteria to take into account in their inspection process. And they went for an off-the-line inspection station. So they were feeding the products in to the station in however much volume they wanted, so in batches. And already just from having the one inspection station, they unlocked a lot of insights, as you see the managing director alluded to here. They were able to correlate some of the defects to humidity along their production line and to the problems that were occurring along the line, and they could fix those earlier on, and that really helped them in their inspection process. And I think one of the main things that they unlocked with AI inspection is having full records of the entire product's inspection from the inspection station. So previously, when they were doing manual inspection, an inspector might start inspecting a product, and as soon as he comes across some sort of fail condition or some sort of defect, he would stop inspecting that product. And what's good about AI is that it comes back to that consistency in inspection that I spoke about, and the complete inspection data that you can start utilizing. It inspects the full product regardless of whether it comes across a defect or not at the start of inspection. And you can start seeing real defect trends and unlocking some insights into those defects because you have that full view of the inspection.
Yeah, this is what they did. These guys, previously, the inspector stopped inspecting whenever they came across a failed condition. Because, of course, why would you keep inspecting a panel when the next ones are already waiting for you and you already know this is a fail? Why would you continue? But then you miss out on the data that Mike just mentioned. Right? Then you don't see the full statistics every single time. And even if you have one inspection station only, those statistics can be extremely valuable. Right? Oh, you're muted, Mike.
Oh, sorry. I thought it would be a good idea to jump into some questions we've received before. I've tweaked them slightly to cover a bit of a broader topic. But I think these are valuable questions and ones we often get asked. And it could help you if you're looking to adopt some inspection solutions. So the first one obviously being like, what are the initial steps? Like how can you go about adopting these solutions? I touched on it a little bit before, where I said you need to really understand what you need in your inspection process and in your QC process. You need to know what are the components that need to be inspected, what are your criteria, what are your actual defects, what are you looking out for. A lot of these things are not addressed beforehand. We've spoken to a few manufacturers who are really enthusiastic about adopting an automated solution, and they're really keen to get going on AI inspection, but they haven't quite clearly defined their QC procedures, and they haven't quite documented something in like the form of a defect catalog, or they're not quite sure what they need in their quality control process. And this is where you kind of get locked into those off-the-shelf solutions where it sounds really good, but it doesn't fit your needs. And I think that's really an important point to consider when looking at AI inspection is don't look for a solution that forces you to fit the solution, rather look for something that fits your procedures and fits your inspection process so that it doesn't disrupt your flows as much as an off-the-shelf solution would. And another, like towards the end here, starting small is obviously great. Starting with a pilot project can prove the capabilities and give you the opportunity to refine those goals that you set out in the beginning and identify where it might be falling short or succeeding really well. But also, in starting small, you need to ensure that there's clear steps to kind of scale up once you've completed that pilot project, and also clearly define the goals of that pilot project, so you know when it's achieved what it needs to achieve, and you can start scaling that up after the fact. And with those points, I think when you're looking for inspection solutions, there's a lot of this advertising that gets put out that it's really simple, it's easy to do, you can do it yourself in minutes, as this advertisement says here. But it's important to note that it's not always that easy. It's definitely not a problem that can be solved in just a matter of minutes. There's a lot of bottlenecks and a lot of problems you're gonna face, a lot of challenges you're gonna have to cross in order to get it working for you and working for your line. And you'll see in these advertisements, there's kind of the promise, which is all these goals and advantages that I've spoken about before. There's a promise of yield increase and a reduction in scrap. And this always sounds great and gets you eager to adopt and gets you enthusiastic about adopting. And when you try these off-the-shelf solutions and you try to do an in-house deployment, you're going to realize that the reality kind of looks a bit more like this. And there's a number of bottlenecks that lead to this output and this result that you're going to come across. And these three bottlenecks and headaches are mainly in data, manpower, and time. Traditional off-the-shelf solutions, they don't really address the data need that you need to get going. You often need thousands of images to kind of train the models to inspect what you need and inspect your products. And it becomes really hard to collect and curate these data sets. And that's where the manpower comes in. You spend hours and hours, days, weeks, labeling defects on your images or labeling certain parts for component verification to kind of train the AI model. And you do all of this without having expertise in the field, and you kind of end up having spent a lot of time, spent a lot of manpower with a failed solution. And this is not obviously a desirable output. To kind of give an example of these bottlenecks, like let's just take a simple product like sheet metal. You wanted to inspect this on your line. You have a number of defect types that you want to inspect. For each defect type, you have to collect samples. You have to document samples of those defects, and you have to use those to train your AI model. And somebody has to sit and manually outline and label where the defect is on the product in order for the AI to know what exactly is it looking out for. So these kind of like stack up and prevent you from achieving high levels of accuracy, and they become tedious, and it takes a really long time to deploy anything that even slightly works on your production line. So it's important to look out for these when adopting solutions. And one kind of innovation that's come recently, and it's a bit of a buzzword at the moment, is this synthetic data. So synthetic data, like I spoke about before, where you're collecting samples of products and samples of defect types to train your AI models. That obviously takes a lot of time, and you might have situations where you have low volume production runs or rare defect types, and you simply can't collect enough data to train your AI models. Synthetic data creates and curates the data for you. That is highly accurate data with highly accurate masks of the defects or components or whatever it is that you're generating data of to train your AI models. And this can be a really good solution to speed up the adoption process and get your system from pilot to scalable inspection solution really quickly and reliably at the end of the day.
Indeed. And as we had in the previous slides, it really works like a human, essentially. That's one of the examples that we like to use quite a lot. Because a human, if you're training a human QC worker, you don't show the human thousands of labeled pictures for every single defect, every product type, right? Instead, you explain the principles, and then the human learns from it. The human synthesizes, if you will, imagines, extrapolates, all of which is basically just brain truth synthetic data about the product, and is able to apply that. Right? And that's what we are doing as well. We do have a bunch additional slides, but in the interest of time, I think we should really remind everyone that we'd really like to get some questions in as well and have time to answer them. Let's see. And there are questions coming in already. One of the problems we have is we have different products with quite a lot of different variants. We are not sure how AI can work around this. Fantastic talking point, and fittingly, there's exactly the slide with it. That's one of the areas where synthetic data shines. When you have lots of variations, because traditionally you would have to go out and do this whole data collection for every single variant, for every defect on every variant, and it just very quickly becomes totally uneconomical to spend all of that time and to gather the data, curate it, and so on. So that's if this is a problem of yours, we should definitely talk, because this is exactly one of the problems that synthetic data is very good at addressing. And there is another question. What is the typical time and resource investment required to integrate this CM platform with our existing inspection stations, production line cameras? Okay, this is very interesting. So if you already have an inspection station, we are also able to interface with that. As in, we like to think of what we do as an end-to-end solution, as in we come in and determine what is the right hardware, we help build it, we deploy it, maintain it, and so on. And then our real work is in the AI. But we are also happy to come in and plug into existing systems. So time and resource investment, I mean, the dreaded answer is always the same. It depends, right? Of course it depends. What do you have in place? How suitable is it? We may have to suggest some adjustments or some modifications. But usually, in terms of resource investment, especially upfront, we do a free feasibility check, as in we're happy to review what you have on hand. We give suggestions what can be done here. And then if you want to move forward with it, depending on the complexity, we're looking at a few weeks to maximum 1 or 2 months to get something going that upgrades what you're currently having. And there's another one. How long does it take to onboard a new product? Usually our promise is to do 24 hours turnaround for product onboarding. If you have an inspection station in place of ours and you want to onboard a new product, in our dashboard you would have an inventory space, and then in that inventory space you have an kind of interactive opportunity to explain to us what it is that you want to inspect and what the parameters are that you want to inspect for this new variant. And that is partially fully automatedly onboarded, or if there's something that is completely new, we may also plug in with one of our engineers, make sure it works. And then the entire pipeline to go from new product input data to a finished inspection solution is all done within 24 hours. So you give it to us one day, and the next day you can start inspecting.
Yeah, unfortunately, I think that's time up already. Went by quite quickly. But what we can do is put together this information for you and send it out to you guys, so that you can review it yourselves and just go through it. Just use it as an educational resource. And obviously, if you have any additional follow-up questions, feel free to email us or just reach out. You can reply to the invite emails that we sent previously, and we'd be happy to chat with you and give you some answers to your questions. But thank you very much for joining, and that's all we have for today.
Thanks, everyone. Don't hesitate to reach out. Always happy to jump on a call. Bye for now.